Okay, so today we're going to look at where a quadratic curve and a line intersect. So before we do that, just have a quick recap when we've done something similar. And that's when we looked at where two lines intersect. And if you remember, we said at this point of intersection, which has got coordinates x and y, the x is the same in both the equations of the line. So that x is the same in the equation of line 1 and the equation of line 2, and the y part of the coordinate is the same in the equation of line 1 and the equation of line 2. And what we said was, therefore, we would solve these two equations simultaneously, or we'd use the fact that if they were both in the form y equals, we would make them equal to each other. Well, the exact situation is the same when you've got a quadratic curve and the equation of a line. At a point A and a point B, they're going to have the coordinate x, y. And in that situation, at the point of intersection, again, we can say the x part of the equation is the same in the equation of the line and the equation of the curve. And the y part of the coordinate is the same in the equation of the line and the equation of the curve. So how are we going to solve this? Let's have a look. We've just said the y is the same in both. So what we tend to do, and I almost always follow this, is I take my equation of my line and I turn it into the form y equals mx plus c. Okay? So I've got my x minus y minus 1 equals 0. To change that into the form y equals mx plus c, I'm going to add y to both sides of the equation, and I get x minus 1 equals y. Okay? And now what I can do is I can substitute that into here, into the equation of the quadratic. So I'm going to take my y, which equals x minus 1, and I'm going to put the x minus 1 where the y was. So I end up with the equation x minus 1 equals, got to do a bit of scrolling here, x squared minus 4x plus 3. Okay, I've got a quadratic equation. What's the only way you can solve quadratic equations is you have to make them equal to 0. So what am I going to do? I'm going to take away an x and I'm going to add a 1 to both sides of the equation. So I'd have 0 equals x squared. Now be careful here, minus 4x, take away another x makes minus 5x plus 4. Most times these will factorise, not always, but in exam questions it's typical for them to factorise. So you've got to find two numbers that are going to multiply to make plus 4 and they're going to add to make minus 5. Well, that tells you they've both got to be negative. So you're going to have minus 4 and minus 1. So either x minus 4 equals 0, so x is 4, or x minus 1 is 0, so x is 1. But we haven't finished the question because we wanted to find the coordinate of the points of intersection. So we actually do need to find the y value. We've worked out here that the x is 4, and we've worked out for point A that the x is 1, but we do need to work out the y part of the coordinate. And for this one, you could use either the equation of the quadratic curve or the equation of the straight line. Now, just because it's easier, I always tend to use the equation of the straight line. So I know y equals x minus 1. So when my x is 4, my y must be 3. And I know again y is x minus 1. So when my x is 1, my y must be 0. So my points of intersection are the point 4, 3 and 1, 0. Okay, And if we look, my point A was, the 0.10, and my point B was a 0.43. Okay, just going to do one more example. This one's slightly more complicated just because fractions get involved, but it's exactly the same process. I take my equation of the line and I turn it into the form y equals mx plus c. So in this case, I'm going to add the 2y to both sides of the equation. So x minus 3 equals 2y. And then I'm going to divide through the equation by 2. Now remember, that means we have to divide every term by 2. So I'm going to say that's a half x minus 3 over 2 equals y. Now I can take this and the equation of the quadratic, and I can make them both equal to each other because I've got y equals in both situations. So I can say a half x minus 3 over 2 is the same as, or is equal to, 3x squared plus x minus 5. Right, at the point where I've got a quadratic to solve. Don't like the fractions, so I'm going to multiply through by 2. I'm going to multiply every term by 2. So x minus 3 is equal to 6x squared plus 2x minus 10. Now, I need to take away the x and add the 3 to both sides of the equation. 0 equals 6x squared. Now I've got to take away an x from this side of the equation, so that's going to be now plus 1x. And now I've got to add 3, so I've got minus 10, add 3 makes minus 7. Okay, now I'm going to see if this will factorise. So I need two numbers that are going to multiply to make 42 and add to make 1. Well, I just did 6 times 7 is 42. So guess what? It's going to be 6 and 7, and it's going to be minus 6 and plus 7. So I'm going to do my grid. I've got my 6x squared. I've got my minus 7 in the bottom. I'm going to put a minus 6x and a 7x there. So what's the highest common factor of that top row? Is going to be 6x. So that's going to be an x, that's going to be a 7, and that's going to be a minus 1. So my brackets become 0 equals 6x plus 7 and x minus 1. Okay, so either 6x plus 7 equals 0. So that means 6x is minus 7, so x is minus 7 sixths. Or x minus 1 equals 0, so x is 1. But again, not quite finished because we do need to find the y part of the coordinates. So if I was going to use it, I would use the linear form of the equation. So I'm going to use this one here. So I've got y equals a half x minus 3 over 2. So let's write that down before I forget it. So I've got y equals a half x minus 3 over 2. Let's just check it was a minus. It was, yeah. And I'm going to write it on this side as well. Half x minus 3 over 2. I'm going to do the easier side. I'm going to do when x is 1. So y is a half times 1 minus 3 over 2. Well, a half minus 3 over 2 is minus 2 over 2. So y equals minus 1. So the first point of intersection is a point 1, minus 1. Right, let's do the slightly trickier side. So I've got a half times minus 7 sixths. Take away 3 over 2. Now, I suspect a lot of you will put this in your calculators, but I've got minus 7 twelfths. If I'm going to take away fractions, they have to have the same denominator. So I'm going to times by 6 minus 18 twelfths. So my y part would be minus 25 twelfths. So my coordinate, which I'm just about going to be able to squeeze in, is going to be minus 7 sixths minus 25 twelfths. Okay, so fractions aren't nice, but you can have a go. Okay, here's 2 for you to do. Press pause, have a go. Sorry, I need to squeeze that in a bit. So you've got the equation of that line, 4x plus y minus 1 equals 0. Find where the 2 intersect and press play to see the solutions. Okay, so number 1. We've got a quadratic. Again, I'm going to rearrange the equation of my line to be y equals. So in this case, I'd have to take away the 4x and add the 1. Substitute that in. You should have got a quadratic equation that said 2x squared plus 7x minus 4 equals 0. It did factorise, and so you should have got an x equals a half and an x equals minus 4. And then substitute that into the equation for the line, and you should have got the 2 points, a half minus 1 and minus 417. Number 2, again, rearrange the equation of the line to be y equals. So you add y equals 6 minus 2x. Substitute that into the y for the quadratic. The equation you should have ended up with should have been x squared minus 2x minus 3 equals 0. Quite a simple one to factorise, and so you should have ended up with the points 3, 0 and minus 1, 8. Okay, so up to now, you have done, or we have done, the situation where we've got a nice quadratic and we've got a line and we have 2 points of intersection. Now, that's exactly the same. We could have a negative quadratic and a line and have 2 points of intersection, okay? And what happens here is you end up with a quadratic to solve that gives 2 solutions, just as we did in the previous example. So we ended up with a quadratic, we got 2 solutions, and that gave us our 2 points of intersection. But there are other things that can happen, because we can have quadratics both positive and negative, but they have a line that just touches. And it can be in different places. It could have a line like that, or they could have another line that just touches. Over on the negative quadratic, could be exactly the situation. They could have a line that just touches, okay? And in these situations, there is only 1 point of intersection. And this is called when we have a tangent. So when we have a tangent, our quadratic gives us 1 solution, okay? And we've come across this before, and it was when we had the same solution twice. Sometimes they call it a single solution to a quadratic equation. Sometimes they call it a repeated solution, because you effectively get the same solution twice. And this was typical when we had the situation where we had something like x plus 1 times x plus 1 equals 0. And so actually we say either x plus 1 equals 0, so x equals minus 1, or x plus 1 equals 0, so x equals minus 1. But really we're just saying x equals minus 1. There's 1 solution, okay? But there is a third thing that can happen. And the third thing that can happen is we could have, again, either a positive or a negative quadratic, but we could have a line that actually never meets either of those quadratics. So we could have the point where there are no points of intersection. Now, how is that going to present itself? Well, how that presents itself is the quadratic that you get actually has no solutions. So remember when you used to use your quadratic formula, and sometimes your calculator would say math error, and we'd always assume that we'd put the numbers in incorrectly. Well, there are points, there are situations when a quadratic has no solutions. And we came across that when we were sketching our quadratic curves. And effectively, it's when it doesn't cross the x-axis. Okay, now don't get confused with the equation for this, because you're saying, yeah, but that crosses the x-axis. It's the equation that we get when we try and make this equal to this. They're two different equations, okay? So let's have a look at the type of questions they might ask. They might say, show that the line y equals 2x plus 1 is a tangent to the curve y equals x squared plus 8x plus 10, and hence find the point where the line meets the curve. Well, let's think about the conditions for a tangent. So if there is a tangent, there's only one point of intersection. And to show that something is a tangent, that's what we've got to show. We've got to show there's only one point of intersection. So actually, we go along the process exactly the same as we did before. We say we're going to try and find the points of intersection. Because at the minute, we were going to assume that there might be two, there might be one, there might be none. We don't know. So we're just going to say, let's find the points of intersection. And how do we do that? Well, we substitute this y equals, which is rather nice to be done for us, into our equation for our quadratic. So we get 2x plus 1 equals x squared plus 8x plus 10. So we've got our quadratic to solve the points of intersection. So we're going to take away 2x from both sides, we're going to take away 1 from both sides, and we're going to get x squared equals 6x plus 9. Now, it will factorise. And we need two numbers that multiply to make 9 and add to make 6. And it's nice and easy because it's 3 and 3. So we can say the solution is x equals minus 3. And as there is only one solution, the line is a tangent, because we had this repeated solution. We've got x equals minus 3 and x equals minus 3 from both brackets. So then it said, hence find the point of intersection of the tangent. Well, again, use the equation of the line y equals 2x plus 1. So y is equal to 2 times minus 3 plus 1. So we've got y equals minus 6 plus 1, so y is minus 5. So the point where we have this tangent is at the point minus 3, minus 5. Okay? Right, another one might be determine the number of points of intersection between the line 7x plus y plus 3 equals 0 and the curve y equals 3x squared minus 2x plus 4. So same process, we're just going to carry on and try and find the points of intersection. So we're going to say y equals minus 7x minus 3, because I'm going to take away the 7x and take away the 3 from both sides. I'm going to substitute that into there. So minus 7x minus 3 is equal to 3x squared minus 2x plus 4. Add the 7x and add the 3. And we're going to get, well, minus 2x add 7x would make plus 5x. And 4 add 3 would make 7. Now I could try and factorise. So I'm going to say I need two numbers that multiply to make 21 and add to make 5. Well, fairly certain that's not going to ever happen. Nope. So then I think, right, I'm going to use my quadratic formula. Okay, in the A level we do need to remember this. So we do need to learn it. Minus b plus or minus the square root of b squared minus 4ac all over 2a. So my b is 5, so I'll get minus 5 plus or minus the square root of 5 squared minus 4 times a, which is 3, times c, which is 7, all over 2 times a, which is 3. Now let's look at this. Right, so in the square root I've got 25 take away, well I've got 4 times 3 is 12, and 12 times 7 is 84 all over 2 times 3, which is 6. And now let's just look at this. 25 take away 84 is going to be negative, okay? You cannot have the square root of a negative number. It is impossible, because no number times itself can ever make a negative number unless you go on to do A-level further maths, and then we create this thing called imaginary numbers. But if for real numbers, you can't have the square root of a negative number. So that means there are no solutions. And if there are no solutions, there are no points of intersection. Okay, so remember, 2 points of intersection, you get 2 separate solutions. If it's a tangent, there's one single solution or a repeated solution. And if there are no solutions, there's no points of intersection. Okay, we've finished. Have a go at the questions on Edmodo, and I will see you next lesson.